This is going to be a tutorial on Arduino, continuing from my introduction video. So this is the second video in this series. And I'm going to get into programming a little bit here. This is this is one of the examples that's given under basics. And this is what's called the bare minimum. This program does absolutely nothing, but you could compile it and it would not come up with an error. Its format is correct. Now, I was talking about curvy braces versus regular braces before, and this is what I'm talking about right here. You're always going to have a void setup. It runs once, and then it goes on to a void loop, which runs in a loop back and forth continuously. Now, there are situations where this word wouldn't be void, and there would actually be something in these brackets. But that's an advanced topic, and for most programs you're going to see until you get really advanced. These are always going to say void, and these are always going to be blank. Void means these are, not really looking for anything in this parameter here. And then there's the so-called curvy brackets. Now look how, with the font I'm running, how similar these look to these. They're very hard to tell apart. So you can actually go into Windows and choose a different font if you're a beginner. I'm kind of used to it now, so it doesn't bug me so much. That's why I haven't bothered. Okay, then here's your main code that'll run repeatedly. And the main code is always going to be between a set of these curvy brackets. Now you're also going to see these curvy brackets if you get into if statements and some of the more complicated statements like that, where stuff's going to be run in between those brackets. So basically that's it. The simple curved brackets usually hold a parameter, or you can put them around any kind of math or anything else you want to do just for clarity. You can actually add them around things or not add them in some places, and it won't disturb your program. The so-called curvy brackets, there's always going to be one to start at the beginning of your procedure and one at the end of your procedure. I went to Notepad to print these out really large just to show you the difference in a more visible way here. These are the so-called curvy brackets, where these are just the simple brackets. On Arduino, learning how to use the Arduino microprocessor, at least my learning process. I'm not going to make this too comprehensive. So at the end of the last video I was talking about the first program you're going to load, and that's Blink. And I was complaining because the Uno I bought came preloaded with Blink, so even after I typed this program in, well, I didn't type it in, I loaded it in like any lazy guy would do. Even, went to examples and went to basic and examples and loaded this basic program called Blink. It's not basic per se, but basic and being basic, you know what I mean. Anyway, it's a C program. So all this program does, initializes a variable LED for 13, which is going to be pin 13 on the Arduino. And then we do pin mode, LED output. And here's where you can play with syntax. LED could be anything. I could make that George, instead of LED. And also output could actually be a 1 instead of the whole word output there. The program doesn't care. It's a little more clear to write it this way. Okay, so that's the setup loop. Runs once and stops. And then it goes to the void loop, which is a infinite loop. So this part of the program, we do a digital write, meaning we turn on the pin 13, which we've labeled LED. It could be labeled George, like I said. And I could write a 1 here, but high means the same as 1. So we turn the LED on high. Now delay, this is milliseconds, so this is a 1 second delay. So the LED is going to stay on for 1 second until it goes to this next statement, digital write, LED low, and again low could be a 0. Turn off the LED by writing a low to it. and then wait for another second before the thing loops back again and keeps going. So it's going to flash on for a second, flash off for a second. Okay, so this came preloaded on my Arduino, so what I had to do to make sure that I was actually doing something was to change these delays around. I changed this delay to 100, and I changed this one to 2000. And that gave me a fast, 100 millisecond blink, followed by a 2-second pause. And once I uploaded that to my Arduino, presuming I didn't introduce any errors, then and I know I've succeeded in uploading my first program. And then I proceeded to play around with it some more. I started playing with random statements, looked up in the Arduino tool. Let's see. So I go to help, and then you can go to reference, and you can find out what different functions do. So I wanted to find out how random worked. And in here I'll probably find my random. There we go. And random's the one you need. Random seed, just you'll have to look that up and you'll figure out what it means. I think I want to be in my documents in Arduino. There we go. Okay, so I went to my documents. I've got two screens. I'm not going to move the camera to show you the other screen. So that's all I did to this program. I think I have an example of it. Let me see if I can find it. And let me go up a level. I think what I really need to do is find documents. And then Arduino. And my next edition was Blink 2. You got to open that folder, then you got to highlight it so it shows in this box, then open it again. Close this out. So here's all I did to this, was to change the numbers. Like I said, I guess I went half a second and then 2 seconds. So that's pretty trivial. Open Sesame, go up a level. So what I do in Blink 3, highlight, open, losing traction of my mouse here. Grab the other mouse. Got two mouses. See, now I'm getting a little more creative here. I started another variable called decount. And I don't know what I was doing here, but I got it flashing multiple times. So here it goes on, here it goes off, here it goes on, here it goes off. And then I have a delay. I guess I'm turning it on again, and then off again. 10 seconds, yes. So that's all I did. I guess it's doing 3 flashes, and then I got this decount thing going, which was going to be a further plan. Oh, then I did this delay. So I'm starting in this program where I gave myself an ever-lengthening delay, which is going to bomb if you run it long enough, because there's only a certain number you can go on before you overflow on your variables. So let's see what I do the next one. And then now I added print functions to it. Took the same program. And all I've done here is add by print functions. which I saw how to do it on a different program. And I had to tweak with them, and I learned how to play with the print function a little bit. Unfortunately, I don't have the Arduino with me, so I can't really show you this. I have an emulator, but God, last time I ran that, it stuffed everything up. Maybe I'll play with that in a minute here. So you see, I added serial begin into my setup loop. Turn the serial port on, set it to 9600 baud, which is kind of a default for most people. And I created a variable flash. What did I do here? Interesting. So I started looking up what these arithmetic functions do. It wasn't that long ago. I'm already forgetting what I did here. But basically what I'm trying to show you is to experiment. I took this real simple program, and now I got it doing more crazy things, and I've rewritten it in different ways. And I got a serial printout. Just a little. But you can see I'm doing more and more different little things to it. And now I notice that it crashed after a certain point. So I got it flashing. I guess I simplified this back. And I've got a print statement telling me how many times it's looped. The delay keeps getting longer every time it loops, the off part of the delay. You also see that I've chained a bunch of commands together, put all my print commands together. I was just trying to see what happened if I needed it to... I noticed there were spaces between some of the statements, and I was trying to figure out if any of that mattered. You can actually put statements in the same line. And if you do that and you get, say I got an error in this long print statement, then all I would do is go put my cursor here and then hit enter. I got another video, I call it return, but because I'm used to my old ancient Atari ways. And all I did is expand that down to single line commands. And then I could rerun the program again and see exactly where the error hit. If there was an error, which there isn't. And what do I do with this last one? I'm not trying to show you anything profound here. I'm just showing you that you need to experiment. Make this thing do a little different variation, so you got control and you start to get a little command over what's going on here. So like what I did this time, I gave it different flash. Looks like I'm flashing 3 times here. And then I got this growing delay thing going again. And looks like I took out the serial commands. Here's my serial command. Oh, here's my serial print. I simplified it though. This is actually an earlier version. That last one I showed you was the later version. But here's my iteration. And this would go for a long, long time. It'll flash 3 times, then it'll flash 3 times pretty quickly again, and then it'll flash 3 times. Ever growing delay. So if you let it sit for hours, you'll see it flash 3 times and go for a long, long pause. But eventually it'll crash because this variable here, this iteration, gets above the maximum number that a integer can be. And what I would need to do to fix that, of course, would be to look up what that number is, and then put a statement in here: if int equals whatever the maximum number is, then int equals some other maximum number just below that, so that it would keep it pegged at that point. Well, there's other ways I could do it too. I could have, say, if it's greater than this number, then have it skip ahead that, that command. So there's a number of ways you could manage that. So it would get to that maximum delay and just stay at that maximum delay, or reset to the load delay if you wanted. all at your command. Okay, another little tip is when you're trying to figure out a certain function or how a certain operator might work, it's just to write the simplest possible program. You just need your void set up and your loop set up. Your void set up and your void loop. And then your closed parentheses and then the curly parentheses to put everything in between. So all this program does is print 0, 1, 0, 1, 0, 1 in a long stream over and over again. And all I'm doing is reversing using that exclamation point. That's what I was trying to test, to see if I could flip the Boolean operator just with that exclamation point reliably and see if it would keep doing it over and over again, which it does. If you run it, you just get a series of zeros and ones. But the whole point is just to test things. You know, maybe even away from your program, open up another window and write a little tiny program like this and see if it's going to do what you think it's going to do. You know, see if you can, if it behaves the way the description said it was going to behave, or the way you interpret that it was going to behave, which it did. Okay, done uploading. All I'll get on the serial monitor is a 0 and a 1 because I flipped that variable. I flipped the value of test to true and false, true and false, true and false. Of course, 0 is false and 1 is true. These are going to be rough and short, so you're be pre-warned, but still you can comment and let me know. I can attempt to answer basic questions.